you can see we really only had one called DUT. And for the connection, we only had one. So I can leave these all as TBD, it doesn't matter, and say done.
So you told that when we want to have all of them on top of each other, we should choose
No,
the
not
star?
yet. No, that's what I'm going to show you right now. So we're going to plot I versus V. And what I did for right now is I'm just showing you, if we leave them all at TBD, let's see what happens. And then I'll show you how to do them all. So let's view that plot. Because I left them at TBD, this comes up before we actually do the plot. And it's the same exact thing,
okay,
right?
gotcha.
Except it's smart enough to know that 0 is the only one, so it filled it automatically. It picked the first reticle, so it picked the first reticle and it picked whatever was the first one of these.
I see.
So if I say done, then we're going to be looking at the IV for 10697, which is that one. Yeah. I can go back and view it again, but pick a different one. Or I can go back, sorry, we view them from up here in the layout. And I can say here, instead of that, I can scroll down and do star 1. Star 1 means, the star means loop, do them all. The difference between 1 and 2 is what order to loop them in. In a plot, they all lay on top of each other, it doesn't matter, but in a tabular report, it will matter. So we'll show that later.
I see.
It's sort of that inner, which is the fastest loop again. Star 1 is the outer, star 2 is the next closest. So now that I put this at star 1, let's see what we get. There's our distributions. They all hung pretty tight. A little bit of difference up here. So then we can go back, and there's things you can do within the tabular report. For instance, we could add grids to it. And on the data, if I went to the Y data, I could say that I'd like the lines to be red instead, or something like that. Or that I'd like, instead of lines only, I'd like lines and symbols for actual data. So you can change up the look of the plot by doing that, because this one has tons of symbols. Putting the symbols on doesn't help for looking at that distribution, right? You would do that more for a... I can click here, edit indices, and it just goes back to this. Instead of that, let me pick one just so you can see the symbols. And there's the symbols, but we have a high density of points, so you're seeing all the symbols.
Can we change this writing over here too?
You can change it by back here in the user preferences under layouts. You don't have to use the full data name in the axis. You can unclick that, and then when you look at the file, when you look at the report, it's just going to show the V and the I. As far as editing them, you can't edit them other than you can change the alias. So, for instance, if you remember, I changed, they're normally called V1I1, I changed it to V and I, but I could have changed this to
I see.
V space and I space, for instance. So you can, that alias you can make whatever you like. So what it's going to do is basically put those, that's where the alias goes to. Okay. So to come back to a more useful plot, we're going to turn off. And by the way, each of these, if we added additional parameters here, if let's say we had multiple currents we wanted to plot, we could do those in Y2, Y3. Each one of these, though, has their own attributes down here for both tabular and scalar. And the reason that it has attributes for both is that you can take a plot and instantly morph it into a tabular report, so it'll follow the attributes that are given. So in our case, we're doing a graph, so this is the only thing that matters, is this here. So for Y1, I'm going to put it back to actual data lines only. Okay. If I had a second trace here, I could put IV dot here again, and if I had I2, let's say, I could have I2 show symbols only, for instance. So each trace can have a different set of attributes. And what you're looking at here, too, just you need to pay attention as to which axis it's on. In general, on a graph, you can do up to 6 things. Up to the ones that are in a different color, that's more for tabular reports, putting things out tabular. Okay. So So I'm going to put that back to none. So let's see what we have for our plot right now. Oh, I'm sorry. I meant to. Let's put a title in. And here we've got. We're just doing auto scale. We could take the auto scales off. So this is what applies to the XY grids graphs here. I'm going to say done. And let's view that plot. And let's do it for all of them. So we see the distribution. Okay. And then if we decide to take it off auto scale, then we could narrow in. We could make a plot that only went from 0.8 to 1 so that we could see that region better and make that a separate plot. We mentioned before the cursor mode, you can kind of put a cursor on here and see the value. Unfortunately, so what you're looking at there, because of the 16 traces, figuring out which one you're on isn't necessarily easy. Oh, sorry, yeah. Did we do one trace? No, that was all 16. Okay, now let's look at a tabular report of the same thing. So let's say add, we'll leave this as tabular, IV tabular we'll call it. And for the tabular report, let's just do the same data, IV dot, V1 and I1, we'll just call them V and I. Okay, and this time though, I want to make this a report that I can print out automatically, like that I can have at the end of the measurement that the software spit it right out. So in this case, I'm going to go ahead and I'm going to define what I really want it to be. So I'm going to make those three, there's no choice. But on the wafer reticle, I'm going to say, I really want the first reticle. Okay? So that's going to define it as being that one. So let's say done, and let's go look at that one. So there's IV tabular, view, and what you'll get are the header lines, and then you've got the V and the I, right? Okay, so, and you can see there's 200 points, and they're all there. If instead I had, I didn't want to do that. If instead, over here, I had said, let's do this as star 1, let's see them all. View. Now it's going to do 16 of these sitting on top of each other. So you can see it's a long file, and it's going to get to the point. There's the next one. There's the next wafer reticle. That's not that easy to read. So what you can do is go back to that report setup, and over here on tabular, we can say column looping options. Loop these indices as additional columns. So if I pick star 1, anything that's been given the moniker star 1 in the looping is, instead of going at the end of the file, it's going to put them out as columns. So now when I look at that, now I can see something that actually that's a little bit easier to see. So I can be looking across each device at a particular current, a voltage. So here I'm looking at minus 8.7 volts. And I'm looking at the current for all 16 things. So I can take that and I can say File, Export Tabular Reports to CSV, and I'm just going to say IV test, wafer. So now if we go look in our directory, oh, okay. You notice it went to see WaveView data, right? I didn't expect it to go there, and that's because I forgot that up here in our directory profile in the training, when I say edit, remember how I said some of these are still not, let's see, export. Apparently, oh, sorry, training. Yeah, see tabular export. Whether it's text or CSV, it's sending it to that. So instead I'm going to say, I'd like that to go to the root directory. And I want my plot exports to go to the root directory as well. So now, whether it's text or CSV or meta files, it's going to go there. So now if we were to come back and view that again, and then if we were to say File, Export, Tabular Report, CSV, now you can see it went to training. Wafer. So now when we go to see wavy data training, now it's right there. Open with Excel, and now we have our data in Excel. So, and that's where I was saying, you know, you could either do some things in Excel. There is an issue in Excel on some of these exports with the way it likes to export the wafer reticle, and I think there's a solution to that.